Am I recording now? Okay, so I'm going to explain again. For the problems when you're dealing with the production of something and you're not given the production function, what you're given is the rate of production. You're given the p prime of t. So assume that p prime of t is this function here, and the t is in weeks. It could be in days, it could be in months, it doesn't matter. But for these two problems, 12 and 13, it is in weeks. So I'm going to explain in weeks. If you want to know the amount of production within the first week, you're trying to figure out this area. That would be the amount of production within the first week. The amount of production or the number of production within the second week would be this one. Yes. So imagine you want to know how many of this item has been produced within the second week and the third week. That means the second region, this one, so I'm going to call them R1, R2, R3, R4. So if you want to know the amount of production within the second week and the third week, you're looking for this. So in terms of integrals, it's going to be integral from 1 to 3 of p prime of t dt. And notice that 0 here represents the beginning of day 1. 0 represents the beginning of day 1. 1 represents the end of day 7 and beginning of day 8. 2 represents the end of day 14, the beginning of day 15. 3 represents the end of day 21 and the beginning of day 22. 4 represents the end of day 28, the beginning of day 29. So for this particular problem, it says, how many bicycles were produced from day 8 to 21? So from the beginning of day 8, which is represented with 1, to the end of day 21, which is represented by 3. So that's why we're trying to figure out this for this problem. Is this clear? So imagine it says how many bicycles were produced within from the beginning of week 2 to the end of week, let's say 3. So this is week 2 and this is week 3. Yes, this is week 1. Region 1 represents week 1. Region 2 represents week 2. Region 3 represents week 3. Yes, so from the beginning of week 2 to the end of week 3 would be the same thing. It's the same as saying from the beginning of day 8 to the end of day 21, right? So another example, if it says from the beginning of week 3 to the end of week 4. Yes, so if it is asking us for the production from the beginning of week 3 to the end of week 4, that means we have to look at the regions 3 and 4. Yes, beginning of week 3 is here. Yes, that's week 3 and that's week 4. So if it says from the beginning of week 3 to the end of week 4, we are looking for the area of these two regions. So our integral in that case would be from 2 to 4. So let's take a look at this one. So for this one, it says, find the number of calculators produced from the beginning of the third week to the end of the fourth week. So this is exactly what I mentioned here, from the beginning of week 3, from the beginning of the third week to the end of the fourth week. So for this problem, you are trying to figure out the areas of region 3 and region 4. So the bounds of the integral have to be from 2 to 4. So for this problem, you're looking for integral from 2 to 4 of whatever function you have, f of t, which is the derivative of the product function, dt. And I did that, I used the 2 and the 4, and I got the right answer. So I checked my answer, that was good. Nope, I did not enter the answer. So let's see. Let me do the calculation again from 3 to 4. That's going to be 1 over 14 minus 1 over 12 times 500,000 plus 10,000. Okay, so you use the bounds from 2 to 4, you're going to get 85,000 over 21, which is the right answer. So again, what really matters is that don't forget that if you're calculating an area from A, if you're calculating a definite integral from A to B, f of t dt, you're dealing with the area of a region that starts at A and ends at B, okay? And with this production function, if you're given p prime of t, you can just think of it like this. 0, 1, 2, 3, 4. This region here, the area of that region is the number of items produced, or the amount of production during the first week. This one is the amount of production, or the number of items produced during the second week. Region 2 represents the second week. Region 3 represents the third week. Region 4 represents the fourth week, and so on. So for this special problem, it says from the beginning of the third week to the end of the fourth week, that's this. That's the amount of production that happened during the third week and the fourth week. So the bounds have to be from 2 to 4. Is that clear now?
Yeah, thank you.
Sure. For this one, the bounds are given from 3,000 to 6,500. So I checked it. The right answer would be integral of the c prime of x dx from 3,000 to 6,500, because you're basically looking for the difference between the cost of producing 6,500 items and producing 3,000 items. So you want to know how much the cost would increase if you increase the level of production from 3,000 items per period. The period could be monthly, daily, whatever, to 6,500. So you're looking for this. So I checked that one and it worked. And for the last one, this last one, it's an initial value problem, actually. You don't need the fundamental theorem for this one. Basically, it's an initial value problem. It says that the marginal cost, which is c prime of x, is given to be 1.92 minus 0.002 x. So you're given this. You're also given another piece of information, the cost of producing one item, which is C1, the cost of producing one item is given to be $562. So with these two pieces of information, you will be able to find C of X. So that is C of X is going to be the antiderivative of this, which is 1.92x minus 0.001x squared plus some C. And this C you can find because you know C1 is 562. So you can use this piece of information to figure out what C is. And the moment you have Cx completely specified, you can calculate the cost of producing whatever number of items. In this case, it is asking for the cost of producing 100 items. So after you have calculated C, you just plug in 100 into the cost function, and that would be the answer. So for this one, it actually related to antiderivatives because it's basically an initial value problem. Okay, so now, do you have any questions about the lecture that you just watched? So from 6.5, you can now do the problems 1 to 27. Problems 1 to 27 from 6.5, you can do them now. I'm going to do one example for you. Or maybe do this one, yeah. And then I will end the class, and you can work on these exercises from 1 to 27. And at the beginning of the next class, you can ask me your questions. So we want to figure out in this example, integral from 2 to 3 x squared, 1 plus 3x cubed to the power of 3 dx. If I want to do the substitution, I would take u to be 1 plus 3x cubed. And then the du would be 9x squared dx. So I can answer this part now. U in terms of x is 1 plus 3x cubed. Du is 9x squared. The dx is already there. I don't need to put the dx because it's already here. Then since x changes from 2 to 3, u would change from, if I plug in 2 into this, I'm going to get 2 to the power of 3, 8. 8 times 3, 24. 24 plus 1, 25. If I plug in 3 into this, I get 3 to the power of 3, 27. 27 times 3, 81. 81 plus 1, 82. So the bounds are from 25. The new bounds are from 25 to 82. Now, this is probably the most difficult part, finding f of u. I would need to do the substitution and then look at the function that I have after the integral. So the integral will become integral from 25 to 82, yes. And now let's do the substitution. I can see that I'm missing a 9, yes. So I have x squared here, but I don't have the 9. So I'm going to multiply by a 9 here and divide by a 9 outside. So I get 1 over 9 u to the power of 3, because this is u to the power of 3, and then the rest of whatever you have, that is this part and this part. So this part and this part together would be the du. So now I can see that my f of u is this function here. So 1 over 9 times u to the power of 3. And finally, I should solve the antiderivative. I get 1 over 9 times 9 times 4 is 36. 1 over 36 e to the power of 4. 25, 82. That's going to be 1 over 36. If I do 82 to the power of 4 minus 25 to the power of 4, I'm going to get a large number. Divide that by 36. Or maybe just enter the answer in exact form. 44, 82, 15, 51 over 36. So let me just check the answers. Looks good. 25, 82. So I hope I did all the calculations correctly. Yep, that's good. So is everything clear about integration, definite integration by substitution? Okay, then. I'm going to end the meeting right now. Work on these exercises from number 1 to 27. And I see you guys next class. Bye, everyone.
Thank you, sir. Bye.
Thank you.
Thank you.